Hello students, welcome back to today's class on perimeter and area. In the last class we have discussed about perimeter and some applications based on that, and we just started area. So let's try to continue our discussion with area and its applications, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is a perimeter? We have already discussed in the last class, right? So that is a complete boundary. The complete boundary of the given figure. But now let's try to discuss about area. In this figure, okay, so whatever the amount of surface enclosed, what do you mean by enclosed? Enclosed means the area inside. Enclosed means the area inside, whatever the area inside, whatever the space inside, so that is called enclosed, right? The amount of surface enclosed by closed figure is called its area. Here this is a square, and the area of a square is the complete all these points, or all the complete space, complete surface. Okay, for example, you have a rectangle or you have a triangle. So for triangle, this complete space is the area of that polygon. Area of that polygon. Even for circle also there is an area. Even for circle also, as a closed figure, you have the shaded thing which has some surface, so we can say that it is having an area, right? So now the major questions are how to find or how to calculate the area of a given figure. So let's try to understand that more about. So to calculate the area using a squared paper. What do you mean by squared paper? Squared paper means it has unit squares in that. It has unit squares in that, right? So this is one square, one unit square. Like 1 unit means 1 centimeter, let's say. 1 centimeter, that's a square. Okay, you have one more square, you have one more square. So the complete paper is squares. So based on that squares, if we take one box as one square unit, so from there we can try to find the area, right? So let's try to take one example. So if more than half a square is in the region, count it as one square unit. For example, I am going to find the area of this figure. The area of this figure, you can see this, right? So the area of this brown figure enclosed. So now we need to find all the squares. How many squares are there? Let me see that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 full length squares are there. 14 full length, that means the complete square is there. But the rest of the things, you can see it's exactly passing the mid, which is actually half. 14 plus half, this is half box, this is also half, okay, plus half, this is one more, 2 and 3. More 3 times, right? Plus half, plus half, plus half. Once again, let me see what all the half boxes we are having. 1, 2, 3, 4, 5. Right? So 14 plus 1 by 2, 1 by 2, 1 by 2, 1 by 2, 1 by 2 will get 5 by 2. 5 by 2. 14 plus 5 by 2, which is 14 plus 2.5, which is 16.5. Right? 14 plus 2.5, 16.5. The area which always uses square units. So answer is 16.5 square units. 16.5 square units. So that is the area of this figure. But not always the boxes are exactly half. Sometimes we may not have the complete box if more than half a square is in the region. Right? In the same figure, let's say we have one more box that is included, and which is more than half, right? So even let's say this part is included. This part is included. You can see this. It is more than half. Half means exactly in the middle. But here it is not exactly in the middle. More than half. Then we can count it as a 1 square unit. We can count that as a 1 square unit, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14, 14.5, 15, 15.5, 16, 16.5 plus 1 complete thing is coming here. That will give you 16.5 plus 1, which is 17.5. 17.5 area Area is always a square units. Area is always a square units. 16.5 plus 1 will give us 17.5 square units, correct? Okay. So moving ahead for the next concept, if exactly half the square is covered, just now we discussed, if exactly half is covered, count it as a half square unit. So exactly same thing. 1, 2, 3, 4, 5. All these are exactly half. You can see the diagram carefully. In that case, you can include half. 1, 2, 3, 4, 5. There are 5 half square units. There are 5 half square units, correct? Okay. So moving ahead, if less than half a square is in the region, if less than half, that means in the same triangle, the same figure, we have one more box which is actually something like this. Okay, this small part. So now you want to add this as one square unit, but you cannot, as it is less than half. As that region is less than half, we say that it is considered as 0. Do not consider the region. Do not consider. So now you may ask me, sir, is this the exact area? No, these are the approximations. These are the approximations where near to the answer, near to the actual answers, correct? Okay. Next one. Right, so we need to find the area of this figure. Let's say each and every box is a 1 square unit. So we have 1, 2, 3 and 4. So total 4 square units plus, it is exactly half, half, half and half. So we have total 4 halves. 4 into half, right? So 4 plus 2 ones to 2s. So 4 plus 2 is 6. 4 plus 4 into 1 by 2, that becomes 4 plus 2, which is 6. But area, I said you, area has some units, 6 square units. 6 square units, correct? Alright, next one. Find the area of the figure below. Okay, so here this is the figure. So I'll draw it once again. So this is one part, next line, the next line, again the next line, and again from the starting, right? So this is how the given figure is there. We need to find the area. First of all, try to bring all the perfect squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So answer should be 12 centimeters square. Answer should be 12 centimeters square. Okay. Find the area of the figure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the complete area is 12 centimeters square. Okay, next one. Find the area of the figure. Okay, we have one more figure. Let me draw that properly. So this is one side, second, third side, fourth, 5, 6, and 7, and this is 8. This is an octagon. What do we say? This is called as octagon. Octagon means 8-sided polygon. 8-sided closed figure, right? So now to find the area, first of all, find how many perfect squares are available. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Anything else more? Maybe this one also, maybe 11. Okay, we don't have any part here. This is also a part here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11, 12. So till here we got 12. We got 12 centimeter, 12 units, 12 square units. But this is exactly half, and this is exactly half. Half 1 by 2, 1 by 2. This is 1 by 2 again. This 1 by 2 again. This 1 by 2 again, and 1 by 2. So how many 1 by 2 schemes? 1, 2, 3, 4, 5, 6. So that becomes 12 plus 6 times of 1 by 2. So 2 ones to 3s. So 12 plus 3 will give you 15 square units. 12 plus 3 will give you 15 square units. Once again, let me check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, right? 15 square units is the area of the given figure. All these are approximately correct. Okay, not exactly. Next. Find the area of the figure below. Now what happened? All that is a square, all that is a circle. Don't worry about that. Just concentrate on the squares. Okay. So here we have 1, 2, 3, 4 and 4. I'm sorry, 4 perfect squares. plus this is more than half, include 1, more than half, include 1, less than 1, delete, less than half, not less than 1, less than half, delete, right? It is included, included, right? So all these are included. Okay, again at the corner. Okay, so find the area. So this is again less than half, this again less than half, so this part and this part cannot be added. These two parts cannot be added. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So that becomes a 12 square units. So that becomes a 12 square units. Let me check that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So that's it. Yes. So the rest of the things which are very less than half will not be included them. Okay. The next one. So formula for finding the area of rectangle. Area of rectangle is length into breadth. Don't confuse with the perimeter. Perimeter is equal to 2 times of length plus breadth. Perimeter is equal to 2 times of length plus breadth. But here, the formula of area of rectangle. Area of a rectangle is length into breadth. This is length, this is breadth. So that becomes length into breadth. Okay. L is the length of the rectangle. L is length of the rectangle and B is the breadth of the rectangle. L is the length and B is the breadth. Okay. Now let's try to move ahead. Let's try to say if this is 4 centimeters and this is 5 centimeters. Okay. This let's say this is 40 centimeters and this is 5 centimeters. 40 centimeters and 5 centimeters. How to find the area? Area is length into breadth. Correct. Area is equal to length into breadth. So 5 4 is 20. So that becomes 200. Area is equal to 200. 200 always units. If you're not clear, just write a square units. It may be centimeters, it may not be. Sometimes in the equation it may be mentioned, it may not be mentioned, but still we need to write that as 200 square units. 200 square units, correct? Right. Let's move forward for the next one. Find the area of the given rectangle. Find the area of the given rectangle. So 2 times of perimeter. If you go for perimeter, it's 2 times of length plus breadth. So 2 times of 7 plus 5. So 2 times of 7 plus 5 is 12. That is 24. Even the perimeter is 24. But now we need to find the area, right? So area is like length into breadth. 7 into 5. 7 into 5 is 35 centimeters square. Square units. Square units. 7 into 5 is 35 square units. Okay. So moving ahead. The length of a rectangular field. So we have a question, some applications based on all this. Let's try to understand that. The length of a rectangular field is 60 meters. Length is given as 60 meters. And the breadth is given as half of its length. Breadth is equal to half of its length, 50. Right? 50 meters. 60 meters and 50 meters. Find the area of the field. The breadth is half of its length. So once again, let me check that. Length of rectangular field is 60 meters. And the breadth is half. Half means not 50. I'm so sorry. Half means half of the length, which is half of 60. Which is half of 60, which is 2 1s to 3s. So that becomes 30 meters. Length is 60 meters and breadth is 30 meters. Find the area of the field. So I told you for rectangle, the area will be always simple. Area is equal to length into breadth. So length 60 into breadth is 30 meters square. 30 meters. So now in the area we need to keep meters square. So 6 3s are 18. 1 2. So that becomes 1800 centimeters square to press. Okay. So L is equal to 60 meters, B is equal to 30 meters, A is equal to length into breadth. 60 and 30, 1800 centimeters square. Area of this rectangle is equal to 1800 centimeters square. Okay. Half of its length, you need to understand this statement. Half of its length, that is half of the 60. Half of the 60 is 30 meters. So if this is clear, you can solve the remaining question. Okay. So the next one. Find the area of rectangle whose length is 4 meters and breadth is 68 centimeters. Once again, see here, 60 meters and half of it. No problem. Okay. And 60 meters, so answer is 1800 meters square. But here it was given as find the area of rectangle whose length is 4 meters. The length is 4 meters and breadth is 68 centimeters. So either we need to convert both into lengths, both into meters, or both into centimeters, right? So find the area of rectangle whose length is 4 meters. Length is 4 meters or 4 into 100 centimeters. So that will give you 400 centimeters. That will give you 400 centimeters, and breadth is equal to 68 centimeters. Breadth is equal to 68 centimeters. So now, if it is asked for perimeter, you can directly go with 2 times of length plus breadth. You can directly go with 2 times of length plus breadth. But now it was given with area. I mean to say area. So you need to find length into breadth 400 into 68. 400 into 68. Or you can also do in another way. You can keep length as well as it is 4 meters. 68 centimeters is 0.68 meters. So meter into meter, you will get meter square, or you get here centimeter square. Okay. So 68 fours, let me check that. 68 fours, 8 fours are 32, 6 fours are 24, 26 24, 25, 26, 27, 272, and yeah. So 68 into 4, 272, and we have 2 zeros. So that becomes centimeter square. 27200 centimeter square. Or if you want to convert into meters, you need to do a lot. Let me tell you why. Because this is also in centimeters, this is also in centimeters. Both you need to convert into meters, right? So here 0.68 into 4. 8 fours 32, 6 fours are 24, 25, 26, 27, 400 and 2. That becomes 2.72. 2.72, that becomes 2.72 meters square. You need to divide with not just 100. You need to divide with 100 into 100 because we have centimeter square. Centimeter square gives that it is a centimeter into centimeter. Here for meters, you need to divide with total not 100, with 100 into 100, that is at 10,000. Okay, so moving ahead, the area of rectangular garden which has 40 meters length is 40 meters, and the area is given as 1120 square meters. 1120 square meters or meter square, whatever it is. Find the width of the garden. So we know that area is given as length into breadth is equal to the area, whatever you get, 1120. So length is 40 meters, right? 40 into B is equal to 1120. So B is equal to 1120 by 40. So now we need to divide. 4 and 4 gets cancelled. So 4 and 112. 4 and 112. For 3s are for 3s are for 2s are 4 2s are 8. We'll get 3 2, and for 8s 8 4s are 32. So that we can keep 28. 112 by 4 breadth, 112 by 4, which is 28 meters. So length being 40 meters, breadth being 28 meters, you will get the total area is 1120 square meters. Okay, so let's try to move forward to the next question. The area of rectangular plot is 2400 square meters. So area is given as 2400 meters square, and its length is given as 1.5 times. And its length is given as 1.5 times to its breadth. 1.5 times to its breadth. So what is the perimeter? So a very simple question. I'm not going to do this now. Okay. Once again, let's try to discuss. The area of rectangle is given. Area is equal to length into breadth. Length into breadth is equal to 2400. Right. So length is 3 by 2 into breadth is equal to 2400. So you can calculate from here what is the perimeter. What is the breadth from the breadth? We need to go back to perimeter, right? So length 3 by 2. It's not actually 3 by 2. 3 by 2 times 1.5 times its breadth. Let me calculate that once again. Let me bring the correct calculations here. Right. Okay. So length is 1.5 times breadth. So breadth is there. B is B, but length will give you 1.5 times of B. So 2 ones 2 plus 1, 3 by 2 times of B. 3 by 2 times of B. So now length into breadth, because the area is given 2400. Length into breadth is equal to length into breadth is equal to 2400. Okay, so you can cancel 3. 3 ones 3 12s. 3 ones 3 12s. That becomes not 12, 3, 8. Sorry, I'm cancelling with the 2. Cancel with 2. Let me erase that. Right. So 3 by 2 into B, that becomes area, that becomes 2400. So 3 and 3 8s. So 800. 3 and 800. Right. So what about here? B into B is equal to 800 into 2. So which is 1600. Breadth into breadth is 1600. So we'll get it is actually equal to 40 into 40. We'll get it as 40 into 40. It is enough to say that the breadth is 40 meters. Breadth is 40 meters. From there you can try to find 1.5 times, which is the length. From there, if you multiply these two, you'll get the area. And sometimes mistakes do happen. I'm saying again, sometimes mistakes do happen. Just please cross check all this and then we can move forward, right? So there are a couple of more applications based on this perimeter and area, which we are going to cover in the next class, right? Thank you so much, friends. Stay tuned to get the next lecture. Thank you.
Hello everyone, welcome back to chemistry class at Gravity Cloud. Let's continue our journey of chapter of materials and things. Now in this class, so far we have understood about the different properties which we can use to classify the materials. Right. Now in the last class, we had gone to about the shining or the appearance property or the lustrousness property of the materials, according to which we can define them in different classes. So today we start from that point onwards. And let's see what is the next property which we can use and according to which we can classify the materials. Now today we will discuss about the transparency. Now when I say transparency, that means what? Now this word, it resembles with the word transparent. It resembles with the word transparent. Right? It resembles with the word transparent. So transparency is actually the property of the materials. It is the property of the materials according to which they allow the light to pass through it. So some materials are transparent. It is the property of the materials according to which they allow the light to pass through them. Simple. Right. Now if I take the example, what does that mean? That means that some materials, they allow most of the light to pass through them and some don't. See, basically when I say transparency is the property of the materials according to which they will allow the light to pass through it. So some will allow it, some will not allow it. Simple. Right? Some materials will be very more transparent, some will be less transparent. Now it all depends upon the amount of light that they allow to pass through the material. If they allow the light to pass through it totally, it is transparent. And if they do not allow the light to pass through the material, it is less transparent or opaque. Understood? So if you take the examples, for example, materials can be classified in 3 categories. The first category is the transparent materials, second category is the opaque materials, and third category is the translucent materials. So based upon the extent, or we can say based upon the amount of transparency, the materials are classified into 3 categories: transparent material, opaque material, and translucent material. So we start understanding the transparent material first. That what are the transparent materials? Transparent materials are those materials which allow the light totally to pass through it. Right? These are those materials which allow the most of the light to pass through them. For example, if I take the glass, let's say this is the glass, or let's say this is ice. Right? Let's say this is glass or ice. And if you glow a bulb, if you light a bulb here, you will see that the light can pass through the glass. Light can pass through the glass very easily. Right? That means the glass is a transparent material. Glass is a transparent material. Simple. Similarly, if you look at here, this is what? This is aquarium. This is my aquarium. And it is made up of glass. And you can easily see what is inside the aquarium, right? Inside this glass pot, you can easily see what is it. We have the fish, these green leaves, then pebbles. Everything is visible inside the aquarium, inside the glass pot. That means the glass is a transparent object or transparent material. Similarly, the plastic. Few of the plastic, this is what plastic, this is called plastic tumbler, right? So few of the plastic materials or few of the plastic jars, they are also transparent in nature. Few of the plastics, they are opaque, and few of the plastics, they are translucent. But some of the plastics like this one, they are transparent in nature. So this is transparent plastic. Similarly, the sheets, plastic sheets. If you look at here, these are the colorful plastic sheets, right? These are the colorful plastic sheets. And each sheet is transparent in nature. That means you can look through that sheet. If I take this sheet and place it here like this, I can look at the back of sheet. Whatever is there at the back of sheet, I can look from the front. That means these sheets are also transparent in nature. So simple, the materials are classified according to their transparency. First is the transparent objects. The objects that allow the light to pass through them, or we can say through which we can see, are the transparent objects. And examples are glasses, some plastics, or we can say plastic sheets. Simple, right? Next type of example or next category of the objects is the opaque objects, or we can say opaque objects. So opaque objects are those materials that do not allow the light to pass through them. Simple. They don't allow the light to pass through them. Look at here. Suppose this is my glass. This is my bulb. Right. Now inside the bulb, what is it? We have the tungsten inside the bulb. Tungsten filament. Inside the bulb, we have tungsten filament. Right? So I have the glass bulb. Inside the glass bulb, I can easily see the tungsten filament. That means this glass is transparent. This bulb is transparent. Right? But if I paint the bulb, if I take this bulb and I paint it with the green color, if I apply green color over the bulb, what will happen? The surface will become green. All of this surface will become green, right? And it will become opaque. It will become opaque. Why? Why does the bulb become opaque? Because now you cannot see inside the bulb. In this bulb, we cannot see inside, that what is there inside the bulb, right? Can you see the filaments? Can you see the tungsten inside the bulb? No. In this bulb we can see, but in this bulb we cannot. That means this bulb is opaque in nature, right? It does not allow the light to pass through it. Simple. Similarly, translucent materials. These materials, they allow some amount of light. They allow some amount of light to pass through them. For example, if you look at these glasses, right? If you look at these glass, they will allow the light to pass through them, but you cannot see through them, right? They will allow the light to pass through them, but you cannot see through them. So I can write it here that these glass allow the light to pass through it, but cannot see through the glass. Cannot see through the glass. We cannot see through the glass, but still they will allow the light to pass through it, right? So such kind of glasses are called the translucent materials. So if you look at this image here, opaque objects, if the object is opaque, it will not allow the light to pass through it. There is no light here, right? The light came from here, the light was absorbed by the object, and there is no light here. In the case of translucent material, the light strike the surface. The light strike the surface of material, right? The light waves, they strike the material, but they pass through it but they passed in different directions, right? They passed in different directions. In the case of transparent material, you see, the light passed through the material directly. The light passed through this transparent material directly, right? So this is how we can easily classify and differentiate the different materials on the basis of their transparency. Opaque, translucent and transparent materials. Next property which we will understand is about the hardness of materials. Now you will see that many materials are there in our surrounding, and few of those materials, they are hard in nature and few of them will be very soft, right? For example, iron. Iron is very hard in nature, right? But if you talk about graphite, we can easily break the graphite pencil, right, with some force, but we cannot break that iron material with that much amount of force, right? That means iron is more harder than the graphite. So the hardness of materials, it depends from material to material. Simple. So some materials are available in nature which are very hard, some are soft. So why the materials are hard? That is important to understand, right? Why the materials are hard? So materials can be hard or soft depending upon how the particles are packed into the solid. Simple. See, every metal, every particle, or we can say every solid around us is made up of particles, right? If I take the ice, if I take this big size of ice, I break it, what will happen? It will form small pieces. That means that big size of ice is made up of small pieces, right? So how these small pieces, they are packed together, the hardness depends upon that. If the particles are packed together very good manner, in a perfectly manner, the particles will be, or we can say the material will be hard. But if the particles are arranged together in a very loosened manner, in a very loose manner, the material will be soft. Simple, right? So for example, look at here. This is my bone. This is the bone. And if you look at here, this is what? This is the fluffy beer, right? This is the fluffy beer. In this case of bone, it's very hard to mend the bone. You can't just push the bone, or we can say bend it, right? Difficult to bend. I can write that bone is difficult to bend. Bone is difficult to bend. But this fluffy beer, it is easy to bend. Easy to change shape, right? Easy to change shape. So why in the case of bone it is difficult to bend, and why in the case of fluffy beer it is easy to change shape? Because in the case of bone, the particles are very close packed, whereas in the case of fluffy beer, the particles are loose, right? Here in the case of bone, particles are closely packed. Closely packed. In case of bone, the particles are closely packed. In the case of teddy bear, fluffy bear, particles are loose. Particles are loose. Now because the particles are loose here, that means it can be changed. Its shape can be changed. Simple, right? Also, in some solids, we can change its shape by simply pressing it. In some solids, we can change the shape by simply pressing it. Like here only, in the case of fluffy beer, you can just press the beer and its size will decrease from this much to this much, right? If you press it from the sides, its thickness will decrease from this much to this much. And if you press it from the top and bottom, its length will decrease from this much to this much, right? So this is how the hardness of the particles depends, hardness of the materials depends. It all depends upon the packing of the particles into the solid of that material. Simple. For example, look at here, this block and this blanket. If you try to press the block, will it change its shape? If you try to press this hard block, Will it change its shape? No. But if you try to press the blanket, right, if you sit on the blanket here, what will happen? It will go down from that place, right? This area will be pressed if you sit here. That means blanket can be pressed, but the blocks, these hard blocks, they cannot be pressed, right? That means the particles in the block, they are very closely packed, but the particles in blanket, they are loosely packed, right? So this is how the hardness of the materials can be understood, depending upon the packing of particles in the material, right? So just take the notes. I give 10 seconds. Just note down the notes. Okay. So next property. Now next property which we can use to classify the materials is regarding the hardness. Okay, hardness is the same. I think it's the same. Same thing. I told you that in some cases we can change the shape of materials just by pressing it. For example, gallium. Gallium is that one kind of material. Basically, gallium is actually metal. Gallium is actually a metal. But if you see here, I am just pressing it right from the top and its shape is changing, right? We are just pressing it from the top and its shape is changing. That means in some solids the shape can easily be changed by just applying the same force. It's the example of that. It is the example of that point, right? So mostly all the solids, all the hard materials, they are used to make the trucks, they are used to make the bicycles, vehicles, or we can say the TV or chair, furniture. All of these things are used, all of these things are made by using the hard materials. So hard materials, they are used to make furnitures, vehicles, whereas the soft materials are used to make the cushions, clothes, all these things, right? Soft materials are used to make cushions or clothes. Simple. Understood? So this is how we can easily understand. How materials can be classified into hard materials and soft materials. Next property which we need to understand regarding the materials is the malleability. Now malleability is what? When it comes to malleability, that is what? Have you ever seen the aluminium foil at home? Right? Aluminium foil is very thin in nature, right? Very thin. And it's a sheet. That aluminium foil is actually made up of aluminium metal, right? That aluminium foil is made up of aluminium metal. So aluminium metal is solid, it's solid, right? Then how can we convert aluminium metal into a sheet? That is possible because of the property of malleability. So what happens that some materials, they can be converted into thin sheets with hammer, right? So if I take the aluminium in my hand, right, and I beat it with the hammer, I can convert that aluminium into sheet. That because aluminium is malleable in nature. Aluminium is malleable in nature. When I say malleable, that means malleability is a property of the materials according to which we can convert them into thin sheets, very thin sheets. Simple. So gold and silver, they are the most malleable material available to us. Gold and silver, they are the most malleable materials available to us. That's why we can easily convert gold and silver into the gold sheets and silver sheets, right? So for example, aluminium. I told you aluminium foils. We get the aluminium foils like this. This is how the aluminium foils look like, right? And we use them for the packing foods like biscuits, chocolates, medicines. All these things we can easily pack by using the aluminium foil, right? So this is how the materials property to convert into sheets, is there. That is the malleability. So malleability means conversion of materials into the thin sheets by hammering is called malleability. Simple. Right? And gold and silver, they are the most malleable metals available to us. Next property is the ductility. Next property is the ductility. Now when I say ductility, that means, okay, have you ever seen the wires which are going outside your home? The electricity wire? Right? Those wires are made up of copper. Now copper is a metal. Copper is a big size solid. Then how can we get the copper wires, thin wires, from that big size solid? That is because of the property of the metal, which is called ductility. So some materials, they can be drawn into thin wires. Some materials can be converted into thin wires, and that property is called ductility. For example, gold and silver. Right. Now you would have seen that the parents or the people, they wear the gold chains or the silver chains. Right. The silver chain is such thin in nature. The thickness of silver chain is very less. How? Because of the property of ductility. Gold can be converted into thin wires. Silver can be converted into thin wires. Right. That's why they are ductile in nature. They are ductile in nature. They are ductile in nature. Simple. Right? For example, if you take 100 milligram of a high ductile metal, if I take 100 milligram of silver, if I take 100 milligram of silver, I can convert it into a wire whose length can be 200 meter. 100 milligram is nothing, it's that much. 100 milligram is that much silver. So I can convert that much silver into 200 meter long wire. So you see, such is the high, strong property of the silver to get converted into wires. Right? Also, copper and aluminium, they are also very ductile, and that's why they are used in the electrical wiring. Right? Like here we see aluminium wires. You see this copper metal. It can be converted into the beautiful wire like this. Right? So all the metals which can be converted into wires can be called ductile solids or ductile materials. Right? So far we have understood the four properties. One is the shiningness, second is the transparency, third is the hardness, fourth is the malleability, and fifth is today ductility. Right? So these properties we have done, and I hope you understood everything properly. In the next class, we come up with the new properties according to which we can classify the metals or materials. Right? So I hope you understood everything. See you in the next class. Thank you.